Hello, welcome back to Engineering Circuit Analysis. We're going to solve this problem here on the board. And in this case, it's a little different because we have a current source, a fixed current source of half of a milliamp. Usually we have a voltage source here. This is a current source, constant current source. We have a feedback resistance of 10 kilo ohms, and on the output side, we actually have two resistors in parallel. That's just to make the flavor of this a little bit different, 2.5 kilo ohms and 5 kilo ohms in parallel with each other. And of course, the power supply linear region is going to be dictated by plus or minus 6 volts in this particular problem. Now the question is, we have labeled the current flowing through the 5 kilo ohm resistor, that's this resistance here, as I5K, and what we're trying to do in this problem is just determine and figure out what the value of this current is. Now when we tackle all of these problems, we're using first principles here, which means we're basically using the properties of the op amps and writing voltage equations, node equations, whatever's required, given the properties of the op amp that we've already talked about, to arrive at what we're trying to find, which is this current. So before you start these types of problems, when you're using first principles and writing KVLs and things, it's usually a good idea to label a few voltages and currents around the circuit of your own placement, so that you can use them as you write your equations. Because right now, if I try to write a loop equation somewhere, I have nothing labeled, so I'd have to make it up on the fly, so it's better to go ahead and just label what we can. And you're free to do and label, anything you want and use the variables that you put in the drawing, as you see fit. So the first thing is to notice that this non-inverting terminal is grounded, like it usually is, which means it's at 0 volts. And so that means because of the virtual short condition, we know that that's 0 volts up here at the inverting terminal, right? So we go and label that. And because we also know that no current can really flow into this op amp, so the current here, if you were to label it, you could certainly label it, but it's going to be 0. That means that because this is a constant current source, really the current is going all the way up and around like this, essentially, is what's going on. And so no current's going to flow in, this current is going to then go up and around. Now instead of putting half a milliamp up here, we're going to just label it, be a little bit more rigorous, and say that this current is going to be defined up here to be I10K, because it's the current through the 10K resistor. And likewise, if we have a current flowing this direction through a resistance, then we know the voltage drop across the resistance has to go plus to minus, and we're going to label that V10K. So you see, we're just labeling voltages and currents, and we're making guesses. Even though, you're pretty confident this is what's happening, it's ultimately just a guess, because you have some intuition, you have some practice and some experience with this, and so you pretty much know that the current's not going to go into the op amp, so the current should go in this direction, and if that's the case, the voltage drop must be in that direction.